Hello, my name is Eric Newkirk. Currently studying EDU 3339 Instructional Methods I at Florida Southern College in Lakeland, Florida. The subject matter today is real world problem solving, set models using fractions. Here's the scenario. Miss Alphabet has a fourth grade math class that consists of 18 students who received word about a local Salvation Army in need of some painting to an office building in the community. She then presented it to the class and asked how can this project be done through real-world problem solving with a set model using fractions. All supplies are provided by the Salvation Army. It's a 3-day project that requires 8 hours total to complete, and only 3/4 of the office building needs painting. Miss Alphabet opened the discussion by rereading the scenario and asked the following question. What are the known factors of this scenario? Replies she received were number of students, 18, supplies provided, how much time and number of days to commit was 8 hours and 3 days. Small office building, only 3/4 of the building needs to be painted. So we're going to start with vocabulary to bring us into fraction so that we can better set up the scenario to resolve the real world issues through math. We're going to start with fraction. Fraction is names parts of a whole or part of a group. Fraction consists of two things. First is the numerator. The numerator is how many equal parts are being looked at. Simply part of the whole. The second part of a fraction is called the denominator, which is how many equal parts there are all together. Simply the whole part. Now here's an example of the fraction model. We have the actual fraction itself, the numeral, and we have this 1 over 5, or we can say 1/5. The 1 here represents the numerator, which is the part, and if you look at the pizza, that will be the part that is missing. And then you have the denominator, which is the 5th or 5, and that's the whole. So even though the numerator shows that there's a part missing, but it still let us know that there was 5 parts to the whole, but only now 1 part is missing. So when we look at this, we're talking about what we can actually see as a part, but also what we can see as the whole, representing a fraction. So let's keep that in mind as we move in figuring out how we are going to resolve the scenario that was presented to us. Okay, now here's the key information from the scenario used for the real world problem solving. Okay, we have 18 students. We have 8 hours and 3 days, and only 3/4 of the building needs painting. So let's work this. Okay, what we're going to start first with is dealing with the office building that needs painting, which is 3 sides only, and then we're going to use the 18 workers for the job to set up our first fraction and additions model. So over here at the far left, you see there's 3 sides, 18 students. So the addition side of this fraction is to break down the sides to the students. So what I done is I used just the simple basics of 1 plus 1 plus 1 equals 3. I did the same thing to the students. I came up with a factor of 6, so that will be 6 plus 6 plus 6. And then if you look at the last portion of that, that means 1 side to every 6 students. So what I did was provided a model using triangles as representative of the size of the wall of the building. And so for the left side, you have the one side, 6 students. You have the front side of the building, which will be also 6 students, and then the right side will be the 6 students. So let's look at the other part that we need to figure out. So here's the second portion that we need to figure out, and that is dealing with the timeline. The timeline is days, which is 3 days, which only giving us 8 hours to complete it. So what we have is 3 days to 6 hours per day is 2 hours, and 3 days to 120 minutes per day is 40 minutes. So what I did was I could only get 3 equal factors of 2, which I had 1 2 left over, so I took that 2 hours, which simply 2 hours means 2 hours, and I broke the 2 hours down to 120 minutes, and then I got a factor of 40, which means I was able to get 40 3 times. So that's where the 40 come from. So if you look at it, equals 1 day per every 2 hours and 40 minutes. So what I did was I set up another model down here where you can actually see how this is broken down. So you have 2 hours 40 minutes day 1, 2 hours 40 minutes day 2, 2 hours 40 minutes day 3. Now let's see how can we put all this together. So solution to the Salvation Office building. We started out with 3 sides, 18 students, which is 1 side per 6 students. Timeline, we started with 3 days to 8 hours equals 1 day to 2 hours and 40 minutes. So what is our conclusion in figuring out how we can get this project done by Miss Alphabet's class? To complete the Salvation Army project, Miss Alphabet's class need to be grouped with 6 student workers responsible for 1 side for 1 day for a total of 2 hours and 40 minutes to complete each side. Applying math concept to real world problem solving beyond the classroom to where we live. So I hope you enjoyed this presentation to give you somewhat of an idea how to take simple fractions and addition and apply it to a real world solution so we can go beyond the classroom and actually apply it to our day-to-day lives. So I thank you for listening. Bye-bye.